This problem is related to stresses. Okay, so a bar of varying cross section is loaded symmetrically as shown in figure. Loads shown are placed on one of the axes of symmetry of cross section. Ignoring self weight, the maximum tensile stress in 2 Newton per mm square anywhere is. Okay, so in this question you have to calculate the maximum tensile stress. Okay, so let's see, so how to solve this problem. In this problem, so calculate the maximum tensile strength, okay, of the two cross sections. Okay, so let us take first cross section. Okay, the next one is take second cross section. So please let us take, this is the one, then so this one is 2. Okay, so just find out the maximum tensile strength. Okay, so our stress, so how to find out the stresses? Already we know that formulas. Then stress equal to, okay, so internal resistance force per unit area. Okay, so that stress formula apply to bar 1. Okay, then so after that apply to bar 2. Okay, so the next one is, so let us consider section 1. Let us consider section 1. Okay, so then section 1, so 50 mm given. Okay, so this cross section is square, so that the area of section 1 equal to 50 mm into 50 mm. So because of this is square cross section. In case of circular, okay, so we are using pi by 4 into d square. Okay, then next A1 is over. So how to calculate the stress, okay, in section 1? So we know that stress equal to load by area. Okay, then next one is, so how much load acting on section 1? Okay, so this 50 kilonewton acting on section 1. Okay, so then P equal to how much? 50 into kilo means 1000, that means 10 cube. Okay, by area, so area equal to 50 into then 50, then sigma 1 equal to, okay, so 20 Newton per mm square, 20 Newton per mm square. So this is the answer of a lower bar, that means section 1. Okay, so then next one is similarly section 2. Section 2. Okay, so what is the area of section 2? Then A2 equal to, okay, so how much given? Side equal to 100 mm. Okay, so this is the square cross section, so that area, what is the area formula? Side into side, then side equal to 100 mm, then 100 into 100. Okay, so then 100 mm, 100 mm into 100 mm. Okay, so this is the second cross sectional area. Okay, then next, so but how to find out the stress? Just to use stress formula, then sigma 2 equal to, so P by A2. Okay, so next, so A2 equal to 100 mm into 100 mm. So because of this is the square cross sectional area. Okay, then so what is the value of P? Next, so see the diagram. So 100 kilonewton, so 100 kilonewtons, so two loads acting on section 2. Okay, then so this 50 also acting on section 2. So because of this load is attached to the section 2. Okay, so how much a load acting on section 2? 100 plus 100 plus 50. Okay, so total, so 100 plus 100, 200. The next one is plus 50. So how much? 250 kilonewtons. 250 into 10 cube by, so area 100 into 100. Okay, then finally sigma 2 equal to 25 Newton per mm square. Okay, so this is the final answer. So which is the maximum tensile strength? So sigma 2 is the maximum tensile strength. Okay, so this is the final answer. Okay, question. Okay, so this question, so given in IES 2005. Okay, so what is the safe static tensile load, okay, for M36 force bolt of MS mild steel having yield stress of 280 MPa and factor of safety equal to 1.5. Okay, so in this question, so which are values given, then factor of safety is given, factor of safety given, then next one is yield stress given, okay, then M36 also given. Okay, so determine, okay, so just a tensile load. So load means what is the symbol of load, so W or P. Okay, but how to calculate, so how to find out the value of tensile load. Okay, so given data, so what are the given, so given data, then so yield stress, then yield stress equal to 280 MPa, so 280 megapascal, MPa means megapascal. Okay, so 280 in terms of Newton for mm square, MPa, okay, just convert into mms. Okay, so 1 MPa equal to Newton for mm square. Then factor of safety also given, then factor of safety equal to 1.5. Okay, but how to calculate the, so tensile load. Okay, so then stress given, some yield stress given, factor of safety is given. Okay, so then next one is just M36 also given. So what is the use of M36? Okay, so M is the metric. Okay, so 36 is the diameter of the bolt. Okay, so this is the designation of bolts. Okay, so M means metric, then 36 is the diameter. Okay, so that, so diameter of the bolt equal to 36 mm. Okay, so diameter of the bolt equal to 36 mm. Then yield stress, okay, then factor of safety given, no problem, then diameter also known value. Okay, so we can easily find out the tensile load. Okay, so we know that one formula, stress equal to internal resistance, that means P by A or W by A. Okay, so just use that formula and calculate tensile load. Okay, then stress equal to, okay, load by area. Okay, so this is the diameter. Okay, so what is the area formula? A equal to, so pi by 4 into d square. Okay, then area known. Okay, so then next one is P. So P is the question mark, this is the unknown value, so this is the known value. Okay, then stress also known value. Okay, but in question, so directly not given. Okay, some yield stress is given, just calculate the stress, but how to calculate the stress? Okay, so then stress equal to yield stress by factor of safety. Okay, then sigma equal to sigma y, that means yield stress equal to how much, 280 by factor of safety equal to how much, so 1.5. Factor of safety equal to how much, 1.5. Then so 280 by 1.5. Okay, 186 point, and sigma equal to 186.67. Okay, so Newton for mm square. Stress, okay, then D already known. Okay, so D known, so that just calculate the area. This question is related to IES 2005, given in IES 2005. Okay, so this is the question. Okay, then what is the safe static tensile load for M36 4C bolt of mild steel having so yield stress of 280 MPa and factor of safety is 1.5. So in this question, then factor of safety given, then some yield strength or yield stress given. Okay, so some M36 into 4 M36 by 4C. Okay, some code is given. Okay, so determine tensile load. But generally, so how to calculate the tensile loads? Okay, so by using the stress formula, then stress equal to internal resistance force per unit area. That means sigma equal to W by A or P by A. Okay, so we will see so how to solve this problem. Okay, next. So what are the values given? So first one is yield stress, then yield stress equal to then 280 MPa. So this 280 MPa in terms of mm, so 280 Newton for mm square. But how to convert so MPa to Newton for mm square? Okay, then 280 into m means mega, so mega means 10 power of 6, then so Newton for meter square. Okay, so this is 280 MPa in terms of meters, but how to convert into ms? So easily, so we can convert into mm 10 power of 6 by, okay, so newtons by, so 1 meter equal to 1000 mm, that means 10 power of 3. Okay, so in this m square, okay, so that so 10 power of 3 whole square, use a 10 power of 3 whole square. Okay, so this is in terms of Newton for mm square. This 10 power of 6, 10 power of 6 cancel, so remaining term is 280 Newton for mm square. So this is the procedure of so conversion, so Newton for meter square to Newton for mm square. That means 280 MPa. 1 MPa means Newton for mm square. Okay. Then so sigma y yield strength. Then factor of safety also given. Then factor of safety equal to 1.5. Okay. So but in this question, so some factor of safety factor given. Okay. So use that formula and find out the strength. Okay, or stress. But how to find out so stress? Okay, from this exact correct stress, okay, by using these two values. Okay, so we have one formula, then stress equal to yield strength or yield stress by factor of safety. So 280 by so 1.5. Okay, so 280 by 1.5, then 280 by 1.5, then equal to so 186.67 in terms of Newton for mm square. Okay, so this is the stress value. Okay, then stress is over. Okay, so what is the stress? General formula, then sigma equal to so load by area. Okay, so in this question just calculate the so tensile load for M36 4C bolt, okay, of mild steel material. Okay, so but how to calculate the load? Okay, so then P equal to sigma into A, then load equal to stress equal to how much? 186.67 into area. But what is the formula of area? Okay, so in this question the cross section is not given, but how to identify so which area formula used in this question? Okay, that means which type of area formula. That means in case of square section, side into side. In case of circular section, then pi by 4 into d square. So in this question indirectly so diameter is given, but how to identify the diameter in this question? Okay, so one code is given, M36. Okay, so this is the designation of bolts, M36. Okay, so M means metric, then 36 means a diameter of the bolt. Okay, so indirectly so they will give in question. Okay, so M36 means, M means metric, this is the designation of volt. Okay, so 36 is the diameter. Okay, so then, so D equal to 36 mm in terms of mm. Okay, so then P equal to 186.67. Okay, so what is the area formula? Okay, so pi by 4 into d square, then d equal to 36 whole square. Okay, so what is the final answer? 180.67 then into, so pi by 4 into d square, 36 whole square. Okay, so 19003.52 in terms of newtons. Okay, sometimes they will, okay, so 19003.52 in terms of newtons. In terms of, they will ask, just find out the, so load in terms of kilonewtons. Okay, so then in terms of kilonewtons, P equal to 190.0. Okay, so kilonewtons. So this is the final answer. Okay, so this is very, very simple problem, but so very important. So what are the given in question? Okay, just identify the symbols, that means yield strength, then factor of safety, then diameters. Okay, so then how to just remember, so how to solve the problem. Okay, so how to calculate the problem, so that is the main important, okay, for all problematic subjects. So what are the given? Okay, so how to use, so given data, but how to calculate problem. Okay, so these are three very important for solving the problems. Question: a steel bar of 40 mm square cross section, 40 by 40 square cross section is subjected to an compressive load of 200 kilonewtons. Okay, so if the length of the bar is 2 meters and so capital E equal to 200 gigapascal, the elongation of the bar so will be equal to how much? Then so this question so given in GATE 2006. Okay, so these are all problems related to stress and strain. Okay, then so what are the given in question? Okay, so then 40 by 40. Okay, so this is the area of square. Okay, then area of square section, then 40 by 40, then 40 into 40, then 1600 mm square. So this is the area of square cross section. Okay, so one value. The next value, subjected to an axial compressive load. Load also given, the load equal to 200 kilonewtons. So what is the symbol of load? So then P, so P equal to 200, so kilonewtons. So then 200 into 10 power of 3 newtons. Load also over. The next, what is the next value? If the length of the bar is 2 meters. Okay, so what is the length of bar? 2 meters. Length of bar equal to 2 meters. Just convert into mm. Then 2 into 10 power of 3 mm over. Okay, and so capital capital E equal to 200 GPa. So GPa means gigapascal. Okay, so what is the meaning of E? E means Young's modulus or modulus of elasticity. Then E equal to 200 GPa. E equal to 200 GPa, gigapascal. Okay, so this is 200 into 10 power of 3 Newton for mm square. Okay, so this value in terms of mm, 200 into 10 power of 3 Newton for mm square. That means 1 GPa equal to 1 kilonewton for mm square. Okay, so then what is the next one? the elongation of the bar so will be, okay, so that means calculate or find out or determine, then delta L equal to question mark. Okay, so just find out the elongation. But how to calculate the elongation? Okay, so we know that one formula, then E equal to delta L by L. Generally we know that, okay, strain equal to delta L by L. Okay, then so just find out the or calculate the delta L. Then L value so given, then strain value so not given. Okay, so we cannot find out from this relation. Okay, so because of, so two values are unknown, so this is the question mark, that means, okay, so find out value. Then next one is E is the strain, so strain is the unknown. In case of strain in given in question, so directly you can use directly this formula. Okay, so this value so not given, so that don't use this formula. Okay, so next one is choose another alternative method. Okay, then area, then load, then L, length. Next one is Young's modulus. Okay, so what is the relation between Young's modulus, then stress and strain? Okay, then capital E equal to stress by strain. Okay, so this is the relation between Young's modulus, then stress, next one is strain. Okay, so then strain equal to sigma by E. Okay, then so strain, what is the strain formula? Change in length by original length equal to stress by Young's modulus. Then elongation equal to stress by elongation into, sorry, Young's modulus into then length. Okay, then delta L equal to stress equal to how much? Stress directly so not given. Okay, so that so calculate the stress value. Okay, so we know that stress equal to P by A. Okay, then stress equal to P by A, then Young's modulus E, then next one is length of the bar. Okay, then delta L elongation equal to, so load equal to how much? 200 into 10 power of 3. This is the load. Then L equal to 2 meters, 2 into 10 power of 3 mm by area. So area equal to how much? 1600 mm square. The next Young's modulus or modulus of elasticity, 200 GPa. So just convert it in terms of mm. 200 into 10 power of 3. 200 into 10 power of 3 Newton for mm square. Okay. Next calculate the value. 200 into 10 power of 3 into 2 into 10 power of 3 by 1600 into 200 into 10 power of 3. Okay, how much? So 1.25 mm. The elongation of the bar equal to 1.25 mm. So this is the final answer.